friends, during our Prime Minister's recent visit to the US, the Micron made an announcement of establishing an assembly, testing, marketing and packing facility in India, which has given us a big breakthrough in the market of chips and semiconductors. India set up its first chip making factory in 1983 at Mohali, but then there was very little progress until the government announced a rupees 76,000 productivity linked incentive scheme. So, what are these semiconductors and chips that is being talked about in today's world? A semiconductor is a substance that has specific electrical properties that enable it to serve as a foundation for computers and other electronic devices. It is typically a solid chemical element or compound that conducts electricity under certain conditions but not others. This makes it an ideal medium to control electrical current and everyday electrical appliances. A substance that can conduct electricity is called the conductor, and a substance that cannot conduct electricity is known as the insulator. Semiconductors basically have properties that sit between the conductor and the insulator. A diode, integrated circuit or the IC, and the transistor are all made of semiconductors. The conductance can vary depending on the current or voltage applied to a control electrode or on the intensity of radiation by infrared, visible light, ultraviolet or X-rays. The specific properties of a semiconductor depends on the impurities or what are known as the dopants that are added to it. So, how do these semiconductors work? These work by the transmission of the electrodes from the positive to the negative. We must understand that these atoms or electrons organize themselves within the atom and they arrange themselves in layers called shells inside an atom. The outermost shell in the atom is known as the valence cell. The electron in this valence cell are the ones that form the bond with the neighboring atom. Such bonds are called covalent bonds. Most conductors have just one electron in the valence cell. Semiconductors, on the other hand, typically have 4 electrons in their valence cell. So, if the valence of the nearby atoms are made of the same valence, the electrons may bind with the valence electrons of the other atoms. And when this happens and the atoms organize themselves into crystal cells, we make most semiconductors with such crystals, mainly with silicon crystals. There are basically 2 types of semiconductors, the N type or the P type. And when these are combined, they form the PNP type of semiconductors or the NPN types. An N type of semiconductor carries current mainly in the form of negatively charged electrons, similar to the conduction of currents in a wire. A P-type semiconductor carries current predominantly as electron deficiencies called holes. A hole has a positive electrical charge equal and opposite to the charge on an electron. In a semiconductor material, the flow of holes occurs in the direction opposite to the flow of electrons. Elemental semiconductors include antimony, boron, carbon, germanium, selenium, silicon, sulfur and tellurium. Silicon is the best known of these, forming the basis of most integrated circuits. Common semiconductor compounds include gallium arsenide, indium antimonide, and the oxides of most metals. We use the widely known gallium arsenides in low noise, high gain, weak signal amplifying devices. So why are semiconductors so useful? That is because the semiconductors form the integrated circuits, and a chip or a IC can perform 1,000 more functions that a normal valve of the erstwhile era was doing. That is why the need for these items have increased many folds in today's world. A semiconductor substance lies between the conductor and the insulator. It controls and manages the flow of electric current in electronic equipments and devices. As a result, it is a popular component of electronic chips made for computing components and a variety of electronic devices, including solid state storage, which are being used in many devices and many items of our daily life. Nowadays, the latest are the radio frequency semiconductors, which are being used in devices or in the radio frequency spectrum of 3 kilohertz to about 300 gigahertz. So the bandwidth is phenomenal and gives us multifarious uses. So with a little insight on what exactly are semiconductors, we will now analyze a little bit on why India wants to be a strength in this field, and we have the capability for doing so, and that is being projected by this government so that the electronic industry can grow and we can attract more manufacturers of chips and semiconductors. There were 3 reasons which were objectionable to India in regards to semiconductors. One was the American Chips Act, which was resisted by India in the World Trade Organization. Then US laws to cut off China was again resisted because India wanted free flow and access of technology for every aspect. And then supply of chips to Russia, which was not liked by India because again it was hampering transfer of technology and also free flow of knowledge. This technology is basically measured in generations, which are called process nodes, which are defined by the minimum feature size or the smallest physical size possible for structures on a wafer in nanometers. Popular process nodes include 40 nanometers, 28 nanometers, 16 nanometers, 5 nanometers and 3 nanometers. As the feature size decreases, the scope rises for the number of components and as well performance of the equipment. So the focus of India turned towards semiconductors because there is a dire need for these, and due to lack of manufacture of semiconductors in the world, there was a lineup or queuing up of many equipments which could not be developed because of deficiency of the ICs or the semiconductors. So if we get the manufacturing capabilities or the manufacturing firms to come into India, because we have the resources, it will create employability for our youth and our citizens. Also, it will cut down the dependence of our people on Chinese technology, which is moving quite fast giving a challenge to the US also. Today, our country is basically importing 80% of the required semiconductors, and creating a robust semiconductor industry in India would offer job creations, like I said, and the Indian IT industry, which today contributes about $150 billion to about $1 trillion to the global IT market. And most of these, or should I put it, nearly about 1/5 of the world's semiconductor engineers are from India. So, if we have such brain, and instead of this brain going out to different countries, if the manufacturing establishments are set up within our country, the economy of our country will grow many of folds. The global semiconductor market is projected to reach about $1 trillion by 2030, up from a market size of $590 billion in 2021. And this growth will be beneficial for our country's economy and also the rise of GDP. And finally, if we have the basis of all electronic equipments, that are the semiconductors, being manufactured in India with our brain, it will be an asset for our communication industry, military, space, cyber, and name it, the things will be there in our country. So semiconductors are today's requirement. So pushing up the establishing facilities or getting countries to invest for setting up their manufacturing establishments here will cumulatively make the economy of our country rise. If you have liked the topic, you can give your comments in the comment box below, and also suggest on any other topic or give your views also. Keep listening to our channel. Jai Hind.